We got a mechanics question about a racing car moving with a nonlinear acceleration, and the acceleration is given into two formulas. For the first 5 seconds, it follows a quadratic equation, and for the next duration, it follows a reciprocal curve. So in part I, they say find the maximum acceleration of the car in the first 5 seconds of the motion. So for the maximum acceleration, dA by dt should be 0 because a varies according to t. So we can try that up. So part I, at maximum acceleration, dA by dt equals to 15 minus 60 equals to 0. 60 is equal to 15, which means t is equal to 2.5 seconds. In part 2, part II, it says find the distance of the car from its starting point when t equals 5. So we need to find the displacement between the starting point and the position where the car is at t equals 5. So since they are talking about the distance, we need to make sure the car doesn't turn backwards so that the distance will not be the same as the displacement. To make sure that, I would like to take the acceleration function, which is 15t minus 3t square. So a equals to 15t minus 3t square. So when the acceleration direction changes, it will be instantaneously 0, which means when we take 3t out, it becomes 5 minus t equal to 0, which indicates t is 0 or t is 5 when the acceleration changes its direction. So that means within the first 5 seconds, the displacement is same as the distance traveled. Now, how do we connect the acceleration into displacement? We could first integrate the acceleration and find the velocity function of the racing car, and then we can integrate it again to find the displacement function of the racing car. So I'm going to do that. Velocity is equal to integral of a dt, and acceleration is equal to 15t minus 3t square dt. So when we integrate this, we would get 15t square over 2 minus t cube. Why? 3t cube over 3, which is going to be t cube. So this is the velocity function. We had to put an arbitrary constant plus c. But we know the car started from rest, so when t equals 0, v is 0. It is given to you. Therefore, 0 equals to 15 by 2 into 0 minus 0 cube plus c, which means c is 0. So we can conclude that the velocity function is going to be 15t square over 2 minus t cube. So this is our velocity function. And then to find the displacement function, we can integrate the velocity function with respect to t. So this would be 15t square over 2 minus t cube dt. So when you integrate this, we would get 15t cube over 6 minus t to the power of 4 over 4 plus c. So we know the particles, the distance which they want us to find is from the starting point. So we need to obviously take the starting point's displacement to be 0. So we can say when t is 0, s is 0. Therefore 0 equals to 15 by 6, 0 cube minus 0 to the power of 4 by 4 plus c, which means once again c is 0. Therefore the displacement function is going to be 15 by 6 is 5 by 2 when we simplify. 5 by 2 t cube minus t to the power of 4 over 4. This is the displacement function for the first 5 seconds. And when t equals to 5, we could say s equals to 5 by 2 into 5 cube minus 5 to the power of 4 over 4, which is 5 to the power of 4 over 4. So we can get this value, which is 625 divided by 4. I will say 156.25 meters is the distance traveled. So that is part 2. And in part 3, they want us to find the value of k. They say the car comes to rest when t equals k, and we need to find the value of k. So the acceleration function is given. So we need to find the velocity at t equals 5. So first thing, we need to find the velocity at t equals 5. So, and then we can find the velocity function for from t equals 5 to t equals k. So I'm going to use that when t equals to 5, the velocity function, we just found it here, 15t square over 2 minus t cube. So that is going to be 15 into 25 over 2 minus 125. So this would be 62.5. 62.5 meters per second. This is the velocity at t equals 5. Now we know from 5 less than or equal t less than or equal k, acceleration is minus 625 t to the power of minus 2. Therefore, the new velocity function is going to be integral of a dt. So, integral minus 625 t minus 2 dt. When we integrate this, we will get minus 625 t minus 1 over minus 1 plus c. So v is going to be 625 over t plus c. We know when t equals 5, v is 62.5, which is 125 by 2. So 125 by 2 is equal to 625 by 5 plus c. So this simplifies c as minus 125 by 2. Therefore, velocity function becomes 625 by t minus 125 by 2. So when v is 0, that is where it comes to rest. They say when t is k, v is 0. So we can say that when v is 0, t is k. So 0 equals 625 over k minus 125 by 2. So 625 by k equals 125 by 2. So this will simplify as k equals 10. This should give us k equals 10. So hope you understood the answer.